Hey everybody, this is Ezra Rice. I am presenting just a brief Docker overview for my IS 542 web development class at Brigham Young University. So, what is a Docker? Well, it's a container that's lightweight, standalone package of a piece of software that includes everything needed to run that software. It means it includes the code, runtime, system tools, system libraries, and settings. They've created it so it works for both Linux and Windows-based apps, and it'll run the same way every time, regardless of the environment. These containers are isolated from its surroundings to help with differences between development and staging environments. With that being said, let's get into this. So this is just an image of a brief outline of why you would want to pick Docker or use Docker. First off, it's lightweight. Docker containers running on a single machine share that machine's operating system kernel, meaning they start faster than virtual machines and they use less RAM. Docker containers are created from images. They're constructed from file system layers and share common files. This minimizes disk usage and makes image downloads faster. Docker containers are secure because they're isolated applications from one another and from the underlying infrastructure of your machine. This limits app issues to a single container instead of the entire machine. So, looking at just a quick comparison between virtual machines and Docker containers. On the left we have just a view of what a virtual machine looks like on a server, and on the right we have what a container looks like on a server. So they're similar in that they have similar resource isolation and allocation benefits, but they function differently because containers virtualize the operating system instead of virtualizing the hardware like virtual machines do. Because of this, these Docker containers tend to be more portable and efficient, so they're easier to distribute and share among other developers, other machines, etc. So looking at the virtual machine, the stuff on the left, we see that a virtual machine it's just one solution to the problem of, well, my code works on my machine, but it's not working on this other person's machine, or it's not working on the production server or the staging server. A virtual machine, it's an abstraction of physical hardware, which turns one server into many servers. Each virtual machine includes a full copy of the operating system. As you can see in this example, I've got one machine, one server, and on that I have 3 different virtual machines. So I've just created 3 new full copies of an operating system, each one having one app installed. So I have 3 operating systems, 3 additional operating systems, and each one of those has one app running on it. And they all include their necessary binaries and libraries. Now, this tends to take up a lot of space and a lot of memory, so a lot of the resources of the host server are being used by these virtual machines. Looking on the right with the Docker containers, we see that it's just another solution to that same problem. Instead, though, it's an abstraction at the app layer that packages the app code and its dependencies together. So it's running in the host operating system using the Docker engine. So it's not replicating the operating systems. We can see that you can have the apps running each app has its packages, the app code, and its dependencies inside of that container. You can have multiple containers running on the same machine and sharing the same operating system kernel with the other containers. Each container is running as an isolated process in the user space. So, they're basically taking up a lot less space than virtual machines, usually on the order of megabytes instead of gigabytes. Virtual machines using on the order of gigabytes. Also, containers tend to start a lot faster. With that being said, we can see that there are some good things to virtual machines and there are some good things to Docker containers. One of the best things about Docker is that they've actually made it so that it's flexible. On the left here we see basically what we saw in the last slide. So on the right, it's just basically the same thing. And on the right, we see a combination of virtual machines and Docker. So we can see how they can be used together. It provides some flexibility in the deployment as well as management of individual apps. One of the nice things about this is you can use it for project management. You're working on app C, and you don't need to be running any of the extra stuff associated with apps A and B in development, so you just boot up your virtual machine containing app C and run the Docker container for that. Or with app B, you could spin up just that virtual machine and then just start up app B's container. It's very flexible in how you use this. You might even want to have a cluster. So you have a cloud-based server and you have a cluster of containers. So multiple instances of your app with a load balancer that gives the front end endpoint or the IP address to the front end, opening it up to the public. You can spin up these multiple containers to act as redundancies for your service or your website, whatever it may be. Now, you might be thinking, but Ezra, why would I want to run my program 4 times or however many times? Well, with any website, any large website, you really need multiple versions of its web servers running for several reasons. One being for scale. You need to handle large traffic, and typically this type of traffic is much more than just one server can handle. Second reason is for failover. If one of your servers crashes, then the site stays up when you have multiple. And the third reason is for speed. If you have a single web page that makes a request for 10 different assets, these requests can go to the different servers that you have set up as asynchronous calls, and then your page loads a lot faster. Well, there you have it. This is just a very brief overview of what a Docker container can do. For more information, I would highly suggest going to the official website that will be listed in the information below, as well as a very useful YouTube instructional playlist for Docker. Thanks for watching.